Right now, 120 light-years away, something is breathing. Not metaphorically, not theoretically, actually breathing. In the constellation Leo, orbiting a star smaller and cooler than our Sun, there exists a world that shouldn't be possible according to everything we thought we knew about life in the universe. Its name is K2-18b, and it just whispered back. The James Webb Space Telescope, humanity's most advanced eye in the cosmos, has detected something in its atmosphere that has no right to be there. A molecule so uniquely biological that finding it anywhere beyond Earth would rewrite every assumption about our place in the universe. That molecule is dimethyl sulfide, and on our planet, nothing but life can make it. For decades, we've been listening to the stars, scanning the void for any sign that we're not alone. We've found thousands of worlds, frozen wastelands, scorched hellscapes, gas giants that could swallow Jupiter whole. But K2-18b is different. When the James Webb Space Telescope turned its infrared gaze toward this distant world, it wasn't looking for little green beings or radio signals. It was doing something far more elegant. It was watching the planet breathe. Every time K2-18b passes in front of its star, starlight filters through its atmosphere. And hidden in that light, in the precise wavelengths that reach us, is a chemical fingerprint. A spectroscopic signature that tells us exactly what gases are floating in that alien sky. The data came back with a confidence level of 99.7%. Dimethyl sulfide, DMS. On Earth, this compound is produced by one thing and one thing only: phytoplankton. Microscopic organisms in our oceans that form the foundation of the marine food web. They release DMS as a metabolic byproduct, a waste product of life itself. We've never found a geological process that can create it. No volcanic reaction, no atmospheric chemistry, no mineral interaction, only life. And now, we've found it 120 light-years from home. So what kind of world could harbor life so far from Earth? K2-18b is what scientists call a Hycean planet, a term coined from hydrogen and ocean. Imagine a world completely unlike Earth. No continents, no dry land, just a global ocean, possibly hundreds of kilometers deep, wrapped beneath a thick blanket of hydrogen atmosphere. The numbers are staggering. This planet is 8.6 times more massive than Earth. Its gravity would crush a human being in seconds. The atmospheric pressure at the surface would be immense, perhaps dozens of times what we experience at sea level. And yet, in that crushing darkness beneath a sky of hydrogen, the temperature holds steady at 49 degrees Celsius. 120 degrees Fahrenheit. Hot, yes, but not boiling, not frozen. Stable. This is where the magic happens. You see, K2-18b orbits a red dwarf star, a type of sun far smaller and cooler than our own. To receive enough warmth for liquid water, K2-18b has to orbit close. Very close. So close that it completes an entire year in just 33 Earth days. But here's the beautiful paradox. Red dwarfs are stable. They don't flare and die like massive blue giants. They don't burn out quickly like our sun will in a few billion years. Red dwarfs burn for trillions of years, which means K2-18b could maintain these conditions, this perfect, stable, life-sustaining environment, for longer than the current age of the entire universe. Time enough for life not just to emerge, but to evolve, to adapt, to diversify, to thrive in ways we're only beginning to imagine. But finding DMS is only part of the story. What makes this discovery truly extraordinary is what we didn't find. Ammonia. When you have a hydrogen-rich atmosphere and no biological processes, ammonia should be abundant. It forms naturally through basic chemistry, nitrogen and hydrogen combining under pressure. K2-18b's atmosphere should be swimming in it, but it's not. The ammonia levels are far lower than any sterile model predicts, and there's only one explanation that fits the data. Something is consuming it. Life is eating the ammonia. On Earth, countless microorganisms use ammonia as an energy source. They break it down, metabolize it, incorporate it into proteins and genetic material. It's one of the oldest metabolic pathways in our biosphere, dating back billions of years to Earth's primordial oceans. Now add this to the presence of methane and carbon dioxide in K2-18b's atmosphere, both detected at levels consistent with biological activity, and a pattern emerges. A pattern we recognize. This isn't just one anomalous molecule. It's an entire atmospheric chemistry that makes sense only in the presence of life. The planet is breathing, taking in, giving out, consuming, producing. This is what a living world looks like from 120 light-years away. Think about what this means. We're not seeing cities or agriculture or technology. We're seeing something far more fundamental. We're seeing metabolism on a planetary scale, the chemical exhale of an entire biosphere. If this discovery holds, if K2-18b is truly alive, then everything changes. Not just for science, for philosophy, for how we see ourselves in the cosmic order. For all of human history, life has been synonymous with Earth. Every organism we've ever known, every ecosystem we've studied, every evolutionary pathway we've traced, all of it happened here, on this one pale blue dot in an incomprehensibly vast universe. We've wondered if we were alone, hoped we weren't, feared we might be, built religions and philosophies around the question, spent billions searching the skies for an answer. But K2-18b suggests something profound. Life isn't rare. It isn't a cosmic accident that happened once in 13.8 billion years. It's potentially common. Red dwarf stars make up 75% of all stars in the Milky Way. If their habitable zones can support worlds like K2-18b, then the galaxy could be teeming with Hycean planets, worlds with global oceans and hydrogen skies where life has been evolving for billions of years. Thousands of them. Maybe millions. Each one a laboratory where chemistry became biology, where molecules learned to replicate, where complexity emerged from simplicity. Think about that. Not just microbial life, but ecosystems, food chains, predator and prey, competition and cooperation, perhaps even intelligence, adapted to conditions we can barely imagine. What does intelligence look like in a world without land, without seasons as we know them? Under a dim red sun that never sets the same way twice? We don't know, but K2-18b might. And here's the most humbling part. We almost missed it. For decades, we looked for planets like Earth, rocky worlds with oxygen atmospheres and moderate temperatures. We assumed life would need our kind of environment, our kind of star, our kind of chemistry. But the universe is more creative than we are, more inventive, more willing to experiment. K2-18b teaches us that life finds a way in places we never thought to look, in crushing gravity and perpetual twilight, in oceans beneath hydrogen skies, on worlds that orbit red suns, in conditions that would kill us instantly, but that other forms of life call home. The cosmos is not silent. We just weren't listening for the right song. The James Webb Space Telescope will observe K2-18b again. More data will come. More wavelengths will be analyzed. The confidence levels will either strengthen or the signal will fade into statistical noise. Science will do what science does: test, verify, challenge, confirm. But right now, at this moment in human history, we stand at a threshold. For the first time, we have legitimate, scientifically rigorous evidence that we are not alone. Somewhere in the constellation Leo, beneath a sky we've never seen, in waters we've never touched, life may be doing what life does, surviving, adapting, persisting against the odds. It doesn't know we exist. It doesn't know we've spent millennia staring at the stars, asking if anyone else is out there. It doesn't care about our philosophies or our fears or our hopes. It simply lives. But we know about it now. And that changes everything. The universe is no longer silent. The ocean is no longer empty. The question that has haunted humanity since we first looked up at the night sky finally has an answer. 120 light years away, something is breathing. And we heard it.